Hello and welcome to Mike's Development Zone. Today we're diving into one of the most important design patterns in software development, the strategy pattern. If you've ever written long if-else or switch blocks to handle different behaviors, then this pattern is going to change your life. By the end of this video, you will understand what the strategy pattern is, when to use it, a modern version using sealed interface. Let's get started. What is the strategy pattern? The strategy pattern lets us swap algorithms at runtime without modifying existing code. In simple terms, define multiple behavior options. Choose one dynamically. No giant if-else blocks. This keeps our code clean, flexible, and open for extension. Here is a problem example. Imagine we're building a payment system. We have multiple payment methods: credit card, PayPal, and bank transfer. The wrong way to handle it. This becomes messy fast. Every new payment method means editing this method, breaking solid principles. The main issue with this approach is that it violates the open/close principle, which states that software should be open for extension, but closed for modification. Adding a new payment method requires editing the pay method, increasing the risk of bugs. It also becomes messy and hard to maintain, as each new method adds more if-else branches, making the code harder to read, test, and manage. Finally, it tightly couples payment logic to the pay method. Now we're going to show a strategy pattern solution with classic Java. Step 1. Create strategy interface. The first step is to create an interface. In a strategy pattern, the interface plays the role of defining the common behavior that all strategies must follow. It acts as the contract for the different algorithm options. This ensures each specific strategy class implements the same method, allowing the behavior to change at runtime without altering the client code. Step 2. Create concrete strategies. The next step is to create concrete classes that implement the interface. In the strategy pattern, these classes provide the actual behavior. Each class gives its own version of the method defined in the interface, meaning each one represents a different strategy. In this example, one class handles payment with a credit card and the other handles payment with PayPal. This allows the program to choose between different payment methods without changing the core logic. Step 3. Context class. The next step is to create a context class that uses the strategy. In a strategy pattern, this class holds a reference to a strategy and delegates the behavior to it. Instead of performing the action itself, it calls the method on the strategy object. This allows the behavior to be swapped easily by providing a different strategy without changing the context class. Step 4. Use it. Boom. We can now swap payment strategies without touching the service code. Finally, you create a client that chooses which strategy to use. In the strategy pattern, the client decides which specific implementation to pass into the context. Here, the program selects the PayPal payment strategy when creating the service. Then it calls the pay method, and the chosen strategy handles the operation. This shows how the behavior can be changed simply by switching the strategy object, without modifying any other code. App output. This is the expected output. Paid $200 using PayPal. So here's what's happening in the classic strategy pattern example, in simple, everyday language. First, we create a PayPal payment object, but instead of storing it as a PayPal payment, we store it in a variable typed as payment strategy. Why do we do that? Because by using the interface type, we keep things flexible. We're saying, this is a payment method. Which one? Doesn't matter, as long as it knows how to pay. Then we pass that strategy into the payment service. So we're basically handing the service a tool and saying, here's how you should handle payments for now. And because the service only depends on the interface, not the specific class, we can give it any strategy we want: PayPal, credit card, bank transfer, all without touching the service code. That's the whole point: plug-and-play behavior. Finally, at the end of main, we call service.pay $200. At that moment, the service says, okay, do your thing, go pay $200. And since we chose the PayPal strategy earlier, the PayPal logic runs, and we get paid $200 using PayPal. A modern version using sealed interface. We start by defining a sealed interface called payment strategy. Sealed interfaces allow us to control exactly which classes can implement this strategy. That gives us two big benefits. First, it protects our design. Only the payment types we explicitly allow can be used. No accidental or unauthorized implementations creeping into our architecture. Second, the compiler understands the full set of possible strategy classes, which gives us better type safety and optimizations. So sealed interfaces let us keep the strategy pattern flexible, while still maintaining strong control and clarity over the allowed behaviors. Next, we create our concrete strategies: credit card payment and PayPal payment. These are marked final because each one represents a specific behavior. Otherwise, it worked pretty much as the classic example of strategy design pattern, shown just before this example. With sealed interfaces and clean class design, we get a modern, safe, and flexible implementation of the strategy pattern in Java 21. And switching behavior is as simple as swapping the strategy object. When should you use strategy pattern? When you have multiple ways to do the same task. When you want clean code without messy if-else. When you need behaviors that change at runtime. When you want to follow solid and open-close principle. When not, to use it. When behavior never changes. When you're only switching between two simple options. For trivial logic, avoid over-engineering. And that's the strategy pattern in Java. Simple, powerful, and honestly one of those tools that makes your code cleaner the moment you start using it. If this helped you out, go ahead and give the video a like, and make sure to subscribe for more Java tips and clean code techniques. Thanks for watching, and I'll see you in the next one.